well, what can you do to help animals? I think there are two things that we can do to help animals. One is leave them alone. So that is, there's so many animals that are fuzzy and cute, and we want to touch them, and we want to have them as pets, and we want to stare at them, and all these sorts of things, and that's fine. You should go to the zoo to do that. But any animals that you see, particularly in New York City, if there's a raccoon that you see, or a squirrel or whatnot, just leave it be. That's one thing you can do for your own safety. But also, animals get stressed. Does anybody feel stress here? Has anybody ever felt stress? Like, let's say you have a test coming up, right? Yeah, you have a test and you feel a lot of stress. All right, well, here's something that's interesting. While you may enjoy staring at that animal and being close to it, it does not like you. It probably doesn't like you. And so it's feeling a lot of stress by you being nearby in general. And that stress can make animals sick. So take the time to support zoos and museums, but generally let the animals eat, and also keeping the environment clean, not littering, that sort of thing.
What do you think is the best type of alternative energy, like nuclear power, wind power?
Well, the problem is none of these are perfect, so we probably need multiple solutions. We cannot just choose nuclear power. As you see, nuclear power probably doesn't work everywhere, like what happened in Japan. In earthquake-prone areas, probably it's not a good idea to have a nuclear power station. There are also hydro energy. You can build a dam somewhere to use massive water, but that could be dangerous too. A dam could break. So when we choose what options we want to replace the fossil fuel energy, we have to really look around and see what's most appropriate. Wind energy, sometimes people use tide energy. Solar energy, I really like solar energy. You're taking more energy from the sun, store it in the battery. But the problem with solar energy right now is it's really expensive to build these solar cells. Really, really expensive. One of my students did a back of envelope calculation, a simple calculation you can do on the back of a napkin or envelope. And he estimated that it's going to cost $5 trillion to keep the entire US lit and light and have electricity cars. So it's a lot of money to focus on one energy resources. So we need more solutions, and we need to build them safely.
Okay, this is kind of a combination question from a few people in various grade levels, but they kind of all work together. Is there a way of kind of capturing carbon dioxide that's in the atmosphere? We know that trees use carbon dioxide. Is that a way of capturing carbon dioxide?
Yes.
And in addition, what is it about the rocks that they love carbon dioxide? So it's kind of two different questions, but both about how do we reduce the amount of carbon dioxide in the atmosphere, and why can't trees just do it all?
Yeah, thank you for that question, because I had the slide here. I was going to introduce my personal heroes. So this really happy guy in a sleeping bag, he's a professor at Columbia University who I work with. His name is Peter Kellerman. So Professor Kellerman is an expert of mantle rocks, and he's the one who proposed that we can first absorb CO2. First, we can concentrate carbon dioxide from air. As you remember, there are only about 0.0384% carbon dioxide in the air, so there's very little, but it's enough to make the earth warm. Or if we add a little bit more, it's going to make the earth warmer. So the second hero of mine, he's also a professor at Columbia, but he's an engineer. So he has been pursuing this device in his dream. So this looks like a peeler, but it's in fact kind of a scrub. It has some organic resin inside. So you can put this thing somewhere in Central Park, or if you don't like the look of it, you can put it, hide it behind a mountain or something. What it does is it has alkaline inside. The resin itself really likes carbon dioxide, so it reacts, absorbs carbon dioxide like how trees do it, but at a much faster rate. So trees and plants also absorb carbon dioxide. and actually use the energy from the sun to make more mass, make more leaves and trunk and everything. But this machine would do it much faster, and what's better is, later you give it a shower, you put hot water through it, the hot water will take all the carbon dioxide out. Then you have, concentrated carbon dioxide. You can put it wherever you want. Okay? So my first hero here proposed that we can just put that hot water deep down into the mantle and let it react with the ophiolite, with the mantle rocks. And the reason that the mantle rocks like carbon dioxide is because they contain lots of calcium and lots of magnesium. So has any of you used a chalk to write on the board? Do you know what's the chalk made of? Calcium carbonate. It's a reaction of calcium with carbon dioxide. And all the chalks you use are similar, basically the same as these veins. Okay? So those chalks are formed much early on, a long time ago. And the rocks that like to react with carbon dioxide are hidden under the earth. I don't know why that is, but it just happened to be the way it is. If it's not the case, if we had these rocks on the surface of the earth, what would happen over time? Let's see, you're in the green shirt. Yeah, we would lose all the carbon dioxide, and we don't want that either, right? We're gonna get too cold. But maybe we would have adapted somehow. Life over, hundreds of thousands of years might have adapted to the colder weather. But the fact is, we haven't. We like the weather it is. We like the climate it is. So we have to find a way to keep it the way it is.